Kia ora everyone. This week's video I'm going to be doing a series of drawings that take you through the plant identification chart that we use when we gather information and observations of all the plants that we use and the vegetation that we have around us. In our chart there's 3 core principles of syntropy which will relate a lot of those categories to. And there's many different categories that are relevant to those core principles, and I hope these drawings will highlight and clarify these as a way of integrating the information into a syntropic design context. So the first principle, strata. So strata is capturing as much sun as you can before it hits the ground. And we do that by understanding the different canopy layers that a plant occupies. And these canopy layers aren't so much to do with the height of the plant, but the degree of sunlight that they require at maturity. Our first layer is the emergent canopy. Then we have high, medium, and low. Again, not only referring to height. For example, here we have an annual version of this where we have the classic three sister situation where we have the pumpkin sprawling out and occupying that mid to lower strata area. Then we have the corn pushing upwards occupying that emergent layer, and we have a bean climbing up that corn capturing the sun on that medium to high layer. In this way, in any consortium, in any community of plants, you'll find that they stratify themselves out into their different niches, occupying different spaces, not creating competition. Another category we want to go through here is frost tolerance. So much like we covered with the sunlight, we want to also observe the degree of frost that a plant can tolerate. When we understand this, we can put it into its appropriate strata in relation to frost as well, where we have the emergent canopy as the most frost tolerant, offering protection to the lower canopies that have decreasing tolerance to frost. Keeping in mind here that we also want to make room for the amount of sun that the plant requires as well. And this is where pruning comes in handy. So within pruning, we have a few different methods. We have coppicing, which means you cut that plant right down to the bottom and just reshoot from a stump, or pollarding, for if you want to maintain the strata that the plant is or prevent any animals from reaching the regrowth. Then we have staghorning, which is where we leave the main branches of the tree but remove all the green foliage. And then there's plants that only can handle a minimal amount of pruning. In those situations, we don't want to remove any more than 30% of the green foliage. So we have coppicing, pollarding, staghorning, or minimal. Next, we want to observe whether the plant is deciduous or evergreen. So evergreen means that it remains with leaves throughout the year, dropping the leaves gradually, and deciduous means the tree is bare at winter, so it drops all its leaves. Within one species of plant, you can have different varieties that drop the leaves at different times of a season. We also look at the leaf litter that is dropped. Brown leaves are high in carbon and the nutrients has been absorbed back into the tree. Green leaves are higher in nitrogen. The leaves have actually retained a lot of the nutrients from that tree. These trees, for example Italian alder, them optimal trees for a silvopastoral system, where animals can actually graze the grasslands in amongst the trees and also eat the leaf litter as an additional fodder. Next, we want to consider the climate zone, whether the plant is naturally from a tropical zone, subtropical, or temperate. And this is valuable information as we can then fine-tune our stratification in our food forest to create that optimal environment. We then also consider the sun intensity that we have. So in our tropical zone, if we look at our strata within a tropical zone, we find that it's actually quite evenly distributed throughout the different stratas. That density is very present in all the different layers because of that high intensity sun that is able to be captured. In our subtropical zone, we have a much higher emergent and high strata compared to our medium and low. This is due to the decrease in sun intensity, and we also have the slight presence of frost in a subtropical zone. And in our temperate regions, our stratification, we have a very little emergent and high strata and a very dense medium-low strata with a lot of herb forms covering the ground, capturing a lot of that sunlight mainly in the lower stratas and the increase in frost. When we understand this, we can fine-tune the degree of sunlight that plant needs, our functional strata density, as well as creating the optimal conditions for each plant to thrive, be that the right amount of sun, frost protection, or ventilation. Our second principle of syntropy is life cycle. This we determine as annual, biennial, short-lived perennial, long-lived perennial, or primary, and you see the years written down there. This is an example of the degree of density we can get away with when we understand both the strata of the plants and these life cycles. We can create and attain that optimal and functional density and diversity over time and space. So for example, all those plants that we saw in that diagram previously, we can see play out like this. So in the first year, we would have our avocado tree, in amongst our tamarillo tree, in amongst our chirimoya tree, in amongst our eucalypt tree, in amongst our inga bean. Also planting in our annuals that we mentioned, corn, beans, and pumpkin. Fast forward to 20 years. Here we have our mature emergent inga bean canopy with our mature fruiting avocado tree happily under the emergent canopy of the inga bean in the high layer. And then nestled among them, we have our chirimoya tree also in fruit production, nestled among them quite happily in that medium to low strata layer. Okay, our third principle of syntropy is succession. So succession is looking at ground formation and vegetation. So we have our establishing phase, accumulation, transitionary, and abundant phase. And this is to do with the soil fertility. And we'll find that the vegetation in these areas differs slightly. So in our establishing phase, that's where we see more lichens and mosses as they gnaw away at bare rock to start generating soil. Then in our accumulation phase, we will have thistle, gorse, tea tree, conifers. All those don't produce any fruit, but are there to open up the soil and accumulate nutrients. This is broken up into individual little life cycles. Those plants in that phase will be very different to the next transitionary phase and the abundance phase. Again, we have the same life cycles of plants. However, they start becoming more lush, and in our abundance phase, again, this is where we see most of our annuals come from, or our main fruit, and we see an even more of an increase in really lush green leaves. So the accumulation phase is a place to repair. Transitionary phase, you start seeing a bit of fruit production, whether it's citruses or raisin tree fruits, as it progresses and transforms into more and more fertility. And the abundance phase is where we see all our annuals, big fruit like avocados and bananas, or apples if you're in the temperate zone. Succession refers to the amount of soil fertility that's there. And we observe this by observing the vegetation. And we can work with that vegetation to generate fertility. So we want to, with syntropy, observe and utilize the vegetation in space to accelerate our regeneration of our land into a syntropic system where we're encouraging life processes as much as we can. The next category we want to look into is propagation. So we can either take cuttings, stakes, which we can push directly into the ground, root suckers or runners, or directly plant things via seed. When we plant things via seed, we have an increased genetic diversity, and we also increase, therefore, the resilience against diseases. When we propagate our plants via cuttings, stakes, runners, or suckers, we are essentially propagating clones of that original tree, meaning that we don't have any genetic diversity. On the plus side, they reach maturity sooner. However, they don't form true taproots as they would via seed. The last category that we highlight in our plant profiles, any unique characteristics specific to that plant. Because the first plant we're going to be releasing is our Tittonia diversifolia, the Bolivian sunflower that is so close to our hearts, I'm going to touch on that as the unique characteristics. So for example, here we observed that is most suited to a situation that's smothered in savanna grasses. So in Northland here in New Zealand, that is our Kikuyu. Our Tittonia is a benefit to us there in its characteristics that it grows from stake, bushes out quite quickly, so it's a fast growing plant and creates that dense shade. But it doesn't just work with shade either. Specific unique characteristic It actually has an allelopathic relationship with savanna grasses, where it actually emits its own chemical against those grasses. Its other characteristics is that it flowers beautifully in autumn, attracting a lot of pollinators. The environment that the Tittonia creates becomes this nurse environment for those trees to germinate and push up through the Tittonia and become a forest again. So in this sense, the Tittonia is a forerunner of the forest. That concludes our breakdown of the plant profile template that we use on all the different plants that we utilize. It is through observing and understanding and collecting all this information on each plant that we can really understand their function, and within that we can stack in both fruit trees, pollinators, native trees, essentially creating a very dynamic and functionally dense ecosystem that we can be a part of as orchestrators. We encourage you to go out and gather this information on as many plants as you can, and if you haven't already, jump up to our interactive tier where we will be releasing our own plant profiles to help and aid in this process as well. Thanks for watching, forward to seeing you all next week.